Hey folks, I recently gave a presentation at a conference about Starlink and the impact it's likely to have on rural service providers. And so I wanted to take a moment just to record that same presentation so we can share it more widely. So to start, we're going to cover what Starlink is and the impact it's having on our solar ecosystem, if you will. We're going to compare it to traditional satellite internet and then take a look at the scope of their plans and how it's likely to impact you as rural ISPs. So at the simplest level, Starlink is a mesh of thousands of low Earth orbit satellites, which is owned and operated by SpaceX, which is one of Elon Musk's companies, and it can be used to provide satellite internet service. So there's a few things to unpack here, and we'll start with the satellite piece. So as of January in 2021, there were 3,372 operational satellites orbiting the Earth. And that seems like quite a lot, but satellites have been around for a long time. For decades we've had satellites up there. But what's surprising is that almost half of those were launched in the last 2 years. So the rate at which we're populating the orbit with satellites is increasing rapidly. And Starlink is a big part of this. So this graph here on the left, the blue bar, shows all the active satellites that are not operated by Starlink. There's about 2,500 there, it looks like. And then we have the green bar, which is all of the active satellites that are operated by Starlink. Okay, so that's a decent portion of the total, maybe 25%, 30% of the total satellites that are up there today are Starlink. But where things get crazy is when we start looking at the other two bars. The yellow bar here is the number of Starlink satellites, a further 12,000 that have been fully approved for launch. So everyone's approved that they can be launched, and Starlink are planning to launch those in the coming years. That takes us to 15,000 plus satellites, of which most, by a large proportion, are Starlink. But then things get really crazy because the purple bar is a further 30,000 satellites, which Starlink have got approval from the FCC, but are still awaiting international approval. So remember, there are only 3,000 satellites, 3,300 satellites operational today from all sources. That's government, military, all commercial organizations, and Starlink by themselves are proposing to launch a further 42,000 in the coming years. So the scope of their ambition here is pretty big. And what are they wanting to do with this? Well, their goal is to offer high-speed, low-latency broadband internet, something which I think most ISPs are trying to do, but where they differ from you is that they want to provide near global coverage of the populated world in 2021. So that is pretty ambitious. But we've had satellite internet for a while, so how come Starlink's any different to what we've seen in the past? Well, if you look at this comparison chart, these are just rough numbers from consumer organizations, we can see that the latency provided by Starlink is 39 milliseconds. I think 20 to 40 milliseconds is the range they quote. 20 to 40 milliseconds latency compared to 500 to 600 milliseconds latency from a traditional satellite internet provider. The bandwidth is also better. They're quoting 50 to 150 megabits per second download, and testing validates numbers in that range, which is a bit better than the traditional satellite internet companies, but more importantly, the latency is dramatically better. If you have 500 to 600 milliseconds of latency, that makes video and voice calling over the internet impossible, whereas Starlink's is actually just as good and perhaps even better than you'd get on the ground, depending on the distances covered. And all of this at a pretty reasonable cost. Now, how is this possible? What's different that makes all of this possible? The key is the first line here, the fact that Starlink is operating low Earth orbit satellites, whereas traditional satellite internet is using geostationary satellites. So let's unpack that. A geostationary satellite is pretty big, about the size of a bus, and they are 22,000 miles away, which is quite a long way away, hence the high latency that we mentioned. But the great thing about the geostationary satellites, as the name suggests, is that they are stationary with respect to the Earth. So you can choose where you put your satellites. You can put them over a location you want to provide coverage, and they will stay there. They orbit the Earth at the same speed that the Earth itself is spinning, therefore giving you a satellite that stays in a single location as far as the Earth is concerned. With a low Earth orbit satellite, they're much smaller and much closer, giving you the lower latency that we talked about, but that also comes with some challenges. Now, critically, because they're so close, they have to move faster. The way gravity and physics work is that in order to stay in orbit, i.e. not fall out of the sky, the satellites need to be moving much faster than the Earth is spinning. And so they're not in a single spot over the surface of the Earth. In fact, they're moving quite quickly. That means that the satellite dishes, the receivers here on the Earth, need to be constantly adjusting to maintain the signal to point at the satellite, and indeed to switch between satellites, because they're constantly having to change which satellite is closest. It also means you need a lot more satellites. Now, Starlink are making a big deal about how they're providing global coverage, and I'm sure that's part of their goal, but also it's kind of inevitable. If you're doing low Earth orbit satellites, you're going to have satellites over all different parts of the Earth because they can't stay still. So you may as well provide it everywhere. So it's both a benefit of this, but it's also just a feature of the technology that they pretty much had to do global coverage. I heard somebody describe this constantly moving satellites thing as a kind of inverse of how things are with roaming cell service. So if you're sitting on a train, as this young lady is, and you're on your cell phone, then the cell towers are in a fixed location, but your phone is moving. And as your phone moves, it switches from one tower to another to maintain signal. In the same or kind of opposite way with Starlink, the satellite dish is staying still on the Earth. I mean, it's really zooming through space at thousands of miles an hour, but as far as we're concerned on the Earth, it's staying still in a single Earth location. But the satellites themselves are moving. And what's cool is there are a couple of sites on the internet where you can actually see in real time where the Starlink satellites are. So I'm currently looking at satellitemap.space, and each of these white dots represents a satellite. And if I zoom in, let me zoom in over the United States here, then you can see each of the satellites along with their names. And if you look closely, even as I'm talking right now, you can see them moving. I talked about how quickly the satellites had to move to maintain their orbit, and you can see evidence of that as we watch. The satellites are moving so fast that we can see them move just as we watch for a few seconds. So you can imagine that a satellite dish, which is trying to maintain coverage, is going to have to switch from one satellite to another pretty regularly in order to maintain a constant signal. So that's all very cool from a technology point of view, but what is the current status? Now, I'm recording this in March 2021, so this may have changed by the time you watch it, but at this time there are over 10,000 beta users, and Starlink are offering beta service across the country. Their claims with regards to latency and download speed are being seen by people. I've read various anecdotal reports and seen various consumer organizations doing testing, and these numbers, 20 to 40 milliseconds latency and 50 to 150 megs download, do seem to be met in real life. The weather does potentially have an impact, but it's actually not that bad. Somebody reported they've been using Starlink service during a heavy snowstorm. I think this is in Maine, and they did see a reduction in speed, 20 meg download, 7 upload during the heavy snowstorm, but they said it was quite usable and certainly better than they would have experienced with a previous provider. The other big thing is that Starlink are getting government funding in order to be able to provide service to rural areas. They received $886 million in the recent round of RDOF funding. So they're definitely competing with traditional ISPs there in getting those subsidies from the government in order to provide service to these remote areas. Now, let's talk a little bit about where they're going with this. So, already to provide internet service across the globe is a pretty ambitious plan, but that's actually not the half of it. You've got to remember, this comes from the mind of Elon Musk, and Elon Musk tends to have pretty grand plans. I'm going to take a slight detour here to give you some examples before we tie this back to Starlink. But Elon Musk, he tends to really think a long way into the future. So one of his plans, one of his companies, is a company called Neuralink. And Neuralink is developing implantable brain-machine interfaces, i.e. a computer chip that gets implanted by tiny robot surgeons inside your skull so that your brain can communicate to a computer. And if that wasn't crazy enough, the reason he's doing this is in part because he's concerned about a Terminator-style future where you have, Skynet with all of these AI robots talking to each other and turning on mankind. And he wants to give us a fighting chance against the Terminators. So he thinks us having these computer-brain interfaces will give us that fighting chance. That's pretty crazy. It was also amusing. Last year he did a public demonstration, which was streamed online, involving pigs, where they had implanted some of these chips into pigs' brains. It didn't look like this photo because obviously they're inside the brain, not outside the brain. But but I thought this was a better image than just a pig. But they did a demo with a pig, and they showed the pig sniffing around, and it turns out that the pig was mostly thinking about food. Big surprise. But hey, hopefully there are more useful insights we'll gain in the future. Another example, this one isn't maybe quite so grand, but it shows the speed at which a frustration or an idea turns into a company. He tweeted in 2016, "Traffic is driving me nuts. I'm going to build a tunnel boring machine and just start digging." And then within 2 hours, he'd started what's called the Boring Company, which is intending to create an underground Hyperloop system between DC and Baltimore, and they've got several other smaller scale projects in the works as well. And they actually have a test tunnel, which you can see videos of. You can see the cars kind of, moving through it, and the prototypes work. So those are some examples, but perhaps the most famous example of Elon Musk's grand plans is his vision for Mars. So he's aiming, his biggest goal is to have a self-sufficient colony on Mars within our lifetime. And more specifically, that means 1 million people to Mars by 2050, based on things he said publicly. His goal is to make it as cheap to move to Mars as it is to buy a house. He also thinks it's going to be good for our economy because obviously there are lots of jobs on Mars. And hopefully this gives you an idea of just how ambitious his visions are. And Mars is interesting because this is actually where things tie back to Starlink. So a big part of the reason he's doing Starlink is because he's not earning enough money from the rockets program that SpaceX does, and he thinks that he can use the revenue from Starlink to fund travel to Mars. He figures if he can get 3 to 5% of the global internet revenue, that will be $30 to $50 billion a year, and that will help build the spaceships that will take people from Earth to Mars so that he can build a colony. And then, of course, once you get to Mars, then SpaceX will build another Starlink constellation around Mars, because obviously people on Mars will need the internet too, and people on Earth will want to be able to talk to the people on Mars, and so they can communicate via these two Starlink constellations. Now, bringing things back down to Earth a little, what does this mean for rural ISPs? What does this mean in practical terms? The first thing to know is Starlink is clearly targeting rural users. As we mentioned, they're getting government funding to provide service in rural areas. Their website talks about how this is ideal for rural and remote communities, and they have quotes on the website about people finally being able to use the internet like a regular person. It's supposed to be a game changer for rural communities. And, as we think about this, it's easy perhaps to worry too much. So, on the one hand, certainly Starlink is a threat, particularly for those more remote areas. If you've got a long copper run, or just in general anything running over DSL, it's not going to be able to provide the latency and bandwidth that Starlink is demonstrating today. So for remote subscribers in your service area, it may well make more sense for them to move to Starlink if they can afford it. On the other hand, Starlink is not as good as fiber. They've talked about improved bandwidth in the future, but where they are today, it's not as good as fiber. So if you're able to provide fiber in towns, in suburbs, in areas where there's good population density, then the local ISP is generally going to be able to provide something better than what Starlink can. And so I think that's the encouragement here, is you may well lose subscribers in those areas that are hardest to service, but your core service areas where most people live, you shouldn't see a lot of competition from Starlink. I hope you've enjoyed this video. If you're not already on our email newsletter, then hopefully we're trying to make technical topics both entertaining and useful for those who are providing voice service. If you're not part of our newsletter, you can join at awardconsulting.com/newsletter. Thank you for watching.